Well, welcome back. In this chapter, we're going to be focusing on the type of math instructions that you can be doing in a PLC controller. So first of all, let's give a basic perspective on math instructions. And so looking at the GUI, this is the menu for these things that we've been using for the Logitech family. The PLC's math function performs arithmetic functions on values with conditional arithmetic instructions. The input logic determines when the executing instruction executes. Unconditional instructions execute with each scan. The basic math instructions are add, subtract, multiply, and divide. And so this is how they would look like. You have the sources and the destination. And so all of that has to be defined. Here's a little bit more example. Source A and source B field can be an input rack location, file address instruction, field, or a fixed value. And so here's an example for input location I1, file address N70, instruction field C5, and just the rest of these things. And so this is how it would be programmed into the PLC. So we have the data type source fields, we have the data types destination fields. So all of these have to be played out. And they're going to have some values associated with each one of those. We have the CPT instruction. This is compute instruction, is executed when copy, arithmetic, logical, or conversion operation residing in the expression field of the instruction is performed, and the result is sent to the destination. So compute, that's useful. Complex expressions, the math advantage of a compute instruction is that it allows you to enter complex expressions in one turn. And so that can be a useful thing. And so here's an example of an expression. Addition instructions. The add instruction adds source A and source B and stores the result in the destination. So straightforward there. The counter program that uses the add instruction, here's an example of how it would look like for a larger PLC program that you're trying to use. The arithmetic status bits for the Logix 500 are found in word 0, bit 0 to 3 are the processor status file S2. The copy, overflow, and zero and sign, these are things that you can have, and so it's important for you to be aware of these types of things that are laid out in this information. You can go look in the textbook for more details on this. So that's a quick overview of the addition instruction. Next, we'll talk about the subtraction instruction. The subtract or sub subtracts source B from source A and stores the result in the destination. Fairly similar to what we talked about for the addition. Here is a vessel overflow alarm program where you would be using the subtract. And so that can be a useful thing to know when you get into that situation or not. Next, we'll talk about multiplication. So MUL is what it stands for, and it multiplies source A by source B and sticks it into the destination, similar to the previous two that we spoke about. Here is a multiple instruction program used to calculate the products of two sources. And so that's how that would look. And the mul instruction used as a part of a temperature control program. And so that would be another example practically of where you could be using this kind of instruction. Next, we have the division. And so the divide instruction divides a value of source A by B, puts it in the destination, similar to what we've had previously on the other three. The div instruction used to calculate the value and that results from dividing source A by source B. This is what the PLC ladder logic program would look like for a simple scenario. The modulo instruction is part of a control logic instruction set. It is used to calculate the remainder after the value stored in the source is divided by the source of source B. You can think of like if you are trying to tell somebody how many minutes are left in the game, the maximum number would be 60 minutes, technically 59, 0 to 59, and just short of 60. But this is what the modulo is trying to do. You never go beyond that level. So it's basically the remainder would be the thing that we're focusing on. So other word level math instructions, we'll get a chance to be thinking about some other useful type of instructions. And so a square root, that would be more complicated, but something that could be useful. So you guys are all familiar with what the square root represents. You have the negative instruction that changes the sign. And so this would be like an inverter that we spoke about when we were talking about digital logic. We have the clear instruction. It clears all the bits or sets all of the values in a word to 0. So that's a useful instruction. Convert to BCD. TOD is the acronym for it. Instruction to use to convert a 16-bit integer into a binary coded decimal value. So that's a useful command. And then finally, convert from BCD, FRD is the instruction that's used to convert a binary coded decimal value to integer value. Here is a program for converting Celsius temperature to Fahrenheit. And so if you know what the actual equation is, you can actually put it in and with your ladder logic to actually convert from that. So that would be a possible way of using your PLC. We have the scale data and scale with parameters, SCL and SCP. At times, data must be scaled or resized before it can be used by the PLC program or a field device. The Logic 500 scale data and scale with parameter instructions are used to perform this task. For the Logic 500 SCL instruction, here's just an example of what you can be doing. Multiply 100 stored by the source address is multiplied by 25,000, divided by 10,000, and added to 127. The result is 377. And so this just gives you an example of the kind of things that you can be doing. So if you want to do a scaling, this is an example of how it would look. Scale analog input uses the SCP instruction. When executed, the SCP instruction places a number between 0 and 1,000 into the destination based on the input signal coming from the transducer into the analog input module. So scale analog output using the SCP instruction. The SCP directs the analog output to provide a 4 to 20 milliamp signal, which is scaled to the value position based on a number between 0 and 100. So another scaling type of operation. For file arithmetic operations, the file arithmetic and logic fall instruction can combine an arithmetic operation with a file transfer. The file add function of the fall instruction is used to perform addition operation on multiple words. So that's can be a useful feature. The file subtract function of the fall instruction is used to perform subtraction on multiple words. So you can do multiple additions, multiple subtractions on things like that. Multiplication in a similar fashion is used to perform multiplication operations on multiple words. And finally, the file divide function of the fall instruction is used to perform the division operation on multiple words. Okay, that's going to end it for this chapter. Thank you very much.